Trigonometric integrals part 3. I won't be able to demonstrate every possible trigonometric integral that you're going to come across, but hopefully with the last two videos and with this video, I at least point you in the right direction. In the last two videos, the trigonometric integrals all involved sine and cosine. So in this last one, I'd like to focus more on tangent and secant. In this example, we have tangent and secant where the secant x is to an even power. If you have an even power of secant x, spin off secant squared x. Then rewrite the resulting even power of secant x in terms of tangent x and use a substitution of u equals tangent x. Let me show you how that will look. All right, first, spin off secant squared x. So secant to the fourth is secant squared times secant squared. Then, rewrite the resulting even power of secant in terms of tangent. Secant squared is equal to 1 plus tangent squared. That's one of your Pythagorean theorems. Next, do your substitution. U equals tangent x. If u equals tangent x, what's du? Du would be secant squared x dx. And hopefully now you can see why we had to spin off secant squared x. Go ahead and do your substitution. Every time you have a tangent x, put in u. And then instead of secant squared x dx, put in du. Then distribute u to the third, integrate, and substitute back. That wasn't too hard. Now, I'd like to show you the reduction formulas that you can find in your textbook. And as I said, I'm not going to demonstrate all four of these formulas, but let's go ahead and focus on the last one, the one involving secant x. So this is the formula I'm going to use. And this is if you have secant x to, some power greater than 1. So it's secant squared, or it's secant to the third, or to the fourth, or to the fifth. And you can tell it's well named. You end up with an integral with secant to a reduced exponent. So let's see this in action. We're going to start off with this problem. And the first thing I'm going to do is I'm going to use my Pythagorean theorem to rewrite tangent squared as secant squared minus 1. Then distribute your secant x. When you do that, you have secant to the third minus secant. And it's the secant to the third that we're going to use the formula on. So let's break this up into two integrals. And I'll use a reduction formula on the first integral. So how would you rewrite that first integral, secant to the third x dx? How would you rewrite that using the reduction formula? See if you can do this. Turn off the video and come back after you've tried it. So n equals 3. All right, let's see how you do. Every time there's an n, I put in a 3. And then I just do the arithmetic. Once you do that, then this is where you are, okay? And what I need to go to a new slide. So I just want, these are the two things that you'll see, where we started and where we are now. So let's move to a new slide. All right, so there we are. Notice that I have half of an integral of secant minus a full integral of secant. So 1/2 minus 1, that's just equal to -1/2. And then just find your integral formula for secant. The integral of secant is log of secant plus tangent, and notice the absolute value sign. And so we have successfully done this problem by using a reduction formula. Take care. Have a great day.